Welcome to today's deep dive. Whether you're catching up on the latest theories or you're just insanely curious, well, we are thrilled to have you here. So I want you to imagine playing a game of pinball.
Okay.
But the table is like infinitely long, the bumpers are completely randomized, and the ball just keeps bouncing forever. You'd think it's impossible to predict where it ends up, right?
Pure chaos, basically. I mean, it's a mathematician's worst nightmare.
It really is. But what if I told you that no matter how chaotic that infinite table gets, the ball miraculously drains into the exact same 3 slots every single time?
Yeah, it's wild.
Right. Well, we've got our hands on this seriously dense, highly technical report evaluating Timothy J. Dillon's theoretical frameworks. And our mission for you today is to decode how a single geometry first paradigm is attempting to solve a century-old math puzzle. And, just casually rewrite the laws of space-time while it's at it. Okay, let's unpack this.
It is a massive undertaking, for sure. But the core theme across both of the frameworks in this report is, it's actually quite elegant. They completely reject the idea of uniform global rules.
Interesting.
Right, so instead they favor localized structural dynamics. Basically, the theory is that local environments dictate the rules.
Right, which brings us back to that infinite pinball machine I mentioned. In math, this is the notorious Collatz conjecture, or the 3x plus 1 problem.
Exactly.
You take a number, if it's even, you, cut it in half. If it's odd, multiply by 3 and add 1. The trajectory wildly expands and contracts, but it mysteriously always lands in a 1-2-4 loop.
Yeah, and proving that universally has been notoriously impossible, well, until this new Omega Genesis framework, that is.
Wait, really?
Yeah, I mean, traditionally mathematicians tried to track every single wild bounce of the ball.
Which traps you in an infinite search.
Exactly. But Omega Genesis uses this compressed odd map to divide the numbers topographically instead.
Okay, but how does a map solve an infinite bouncing ball problem?
Think about laying a grid over the pinball table to study the structural tilt of the table itself, rather than, just watching the silver ball bounce around.
Oh, I see.
The framework maps out an expanding zone, which it calls the entropic transient membrane, and a contracting zone, the syntropic capture basin.
Okay.
And the math proves that a trajectory physically cannot remain in the expanding zone forever. The structural tilt literally forces it into the contracting basin.
Wow, that makes so much sense. By proving the ball can't stay in the outward bouncing zone forever, you basically trap this mathematical chaos into a finite, verifiable grid.
Precisely.
It turns an infinite mystery into a bounded checklist. But here's where it gets really interesting. If mapping localized zones tames infinity in math, what happens when we apply that exact same logic to the physical universe?
Well, you get curvature variable physics, or CVP. We take that localized geometry and project it right onto the cosmos.
I have to push back here, though. The report says this physical framework dismantles global Lorentz invariance. Wait, doesn't that break the ultimate rule that the speed of light is constant?
What's fascinating here is that it absolutely shatters that rule.
Yeah.
CVP introduces the Dillon operator, written as C equals C of R.
Yeah.
It argues that the speed of light is not a fixed, rigid number. It dynamically bends and adapts to local scalar curvature.
Okay, let's clarify scalar curvature for a second for the listener. We're basically talking about the bumpiness, or the specific shape of space in one tiny, isolated area, right?
Spot on. Think of the universe not as a perfectly flat, paved highway with a universal speed limit.
Right, like we usually do.
Exactly. But instead, as a topography filled with dirt roads, valleys, and hills, the speed of light literally adjusts its pace depending on the geometric neighborhood it's traveling through.
So if light naturally bends and changes speed based on local potholes, we don't need to invent massive theoretical band-aids to explain why the universe looks the way it does.
That is the real breakthrough. Right now, physicists conjure up invisible dark matter to explain why galaxies rotate at strange speeds.
Or inflationary epochs for the early universe, right?
Yeah, exactly. CVP argues that those anomalies are just light and energy behaving naturally according to local geometry.
So no invisible mass required?
None at all.
So what does this all mean? Dark matter is cool, but how does bending the speed of light actually matter to you and me walking around with our smartphones?
Well, CVP scales from galaxies all the way down to our gadgets. Think about the future of telecom, specifically 6G and 7G networks.
Okay.
The ultimate goal is the Internet of Bio-Nano Things, or IOBNT. We basically want to connect macro-scale terahertz waves directly to microscopic cellular molecules.
But shoving a massive high-speed wave into a tiny biological molecule sounds like a recipe for friction. Like trying to park a bullet train in a bicycle rack.
Right. The scales are entirely incompatible, which normally destroys the signal, but CVP introduces a mechanism called toroidal refractance.
Toroidal refractance.
Yeah, it uses geometric loops toroids, which basically look like microscopic donuts.
And how does a microscopic donut prevent the bullet train from crashing?
So the massive wave enters this microscopic loop. Instead of hitting the cellular boundary all at once, the wave spins through the toroid.
Oh, I get it.
And as it cycles, its propagation speed physically and dynamically adapts to the specific scalar curvature of the biological molecule.
It acts like a step-down transformer. The wave slows down, bending to match the local microscopic shape before it exits the loop.
You nailed it. It creates a frictionless bridge. This mechanism allows seamless communication between giant digital antennas and microscopic biological systems, all without degrading the signal.
Incredible. We just went from tracking wild integer pinballs to bending the cosmic speed of light, all the way down to microscopic donut transformers powering our future 6G networks.
If we connect this to the bigger picture, it really proves how a single shift in perspective, moving from rigid global rules to flexible local geometry, can unlock entirely different disciplines.
It really does. And leaves you wondering, if the fundamental speed limit of the universe naturally bends to its local environment, well, what other absolute physical laws are actually just localized illusions waiting to be exposed?